Hello, today we are doing question 9.40, and this question asks us to name each of these ethers and epoxides. So we're asked to give the IUPAC namings, and you gotta remember your naming rules. So first, I like to identify your longest parent chain, and then all your functional groups attached to that. So let's look at the first problem here, problem A. We see that we have two cyclohexanes, which are attached together with an each ether. So we have a dicyclohexane with ether in between them. So if I were to name that, you would have dicyclohexane plus an ether. Now I need to stitch these two words together. So using your suffixes, dicyclohexyl ether. Next, for B, we need to identify the parent chain. So we need to count our carbons. And remember, you want your substituents to land on the lowest number carbon. So if I were to count from this side, 1, 2, 3, 4, 5, 6, 7. Now we know that it's a total of 7 carbons, so it would be a heptane, straight chain hydrocarbon. However, your functional groups would be on carbon 4 and 5. If I were to count the other side, starting from the other side, 1, 2, 3, 4, 5, 6, 7, we see that now our functional groups are in carbon 3 and 4. So we need to count according to the red ink here, starting from the right, going to the left, because that gives the lowest number for our substituents. So if you see on carbon 3, we have 3 carbons and oxygen. So that's a propane with an oxygen. So that's what we call a propoxy group. Just like in previous examples, we saw an isobutoxy and a methoxy group. And now on carbon 4, we have 2 methyls. So we have a dimethyl group. And remember, I like starting with your longest chain. So I will write, we have a heptane. And attached to that heptane on carbon 3, we have a 3-propoxy group. And attached another functional group, we have 2 methyls on carbon 4. So we need to do 4,4-dimethyl. So to represent that we have 2 functional groups, we need to act as their individual functional groups. And we have 1 methyl, 2 methyls, so that becomes dimethyl. But now, because we're acting as their individual functional groups, we must add 4,4. We can't just have it as a single 4, because these are 2 unique substituents. Now, moving on to C. Once again, we will count our longest chain starting at the side, which will give our functional groups the lowest number ranking. So we have 1, 2, 3, 4, 5, 6. So this is our longest chain. So 6 means it's a hexane. And we see that we have an epoxide here. And the epoxide is originating from carbon 1 and 2. But also on carbon 2, we have a methyl substituent. So we see that we have one substituent being the epoxide, the second substituent being this methyl group. So I'll name it starting from my long chain being a hexane. And attached to this hexane, I have a 2-methyl group, but I also have an epoxide which exists between carbon 1 and 2. Epoxy. This is the name for this molecule. And the very last problem here, the very last sample here, we have 2 tert-butyl groups attached together with an ether. So you can think of 2 tert-butyl groups. We need to make a di-tert-butyl, and same as problem A, we need to add ether at the end. So we can say we have a di-tert-butyl ether. That's the name of that.